Hello, like to say again, I'm Fritz. In this tutorial, I will show you how to control this servo drive from JTEKT. Actually, it's a Japanese brand, and with the Codesys controller 7508215 that with pure Codesys runtime inside. So it depends on your firmware version that you can run Codesys or copy. That depends on your firmware. Okay. But now the WAGO, it prefer you to update your controller to the newest version to use the pure Codesys runtime. So here I have a DI module, DIO module, and it's AI module, AO module, AI modules, and I only use the DIO in this time, and all its this cable is wired to the IO terminal board, and this IO terminal board is connected to the drive, and here's the power. And here's the servo motor exactly, and here I'll have a small switch. It's called switch to simulate a e-stop, and here's the lamp that will show you if there's any error of the servo drive. As see now say A001V, it means that there's an alarm is happening inside the drive, so that's also why this lamp is turning on. Okay, for the basic explanation here is enough. Then I will shift my video to the slide to show you, to explain it be more detailed inside my conversion. Or okay, so here is the slide of my conversion in this time. As I mentioned before, WAGO PLC is used in this tutorial, and it is a PFC 200 family PLC with model number 7508215. Then depends on your firmware version, you can run pure Codesys inside your WAGO controller. And the left hand side is the JTEKT Servo Drive. It's using in this time, and this servo drive is the main Japan, and you can this time I will show you how to control this servo drive by using digital input and output. But actually, the theory are the same. Although you say field bus or use anything, I think the theory is not so different. Okay, so here's the IO mapping in here, and in the servo drive setting, you can in JTEKT servo motor, you can feel free to edit any digital input or digital output to any signal that you want to, like. That depends on applications. So I would like to notice you that you no need to 100% follow what I make in this time. You can create your own application. This depends that with any free IO mapping. So but there's one point that I would like you to take care, and this digital input and digital output, this view is from the servo drive. So it means this digital input will be the output of your PLC. That means your PLC will need to pass a signal to digital inputs of your servo drive to turn on your drive, to trigger the command, to reset your alarm something. And also for the digital output inside the servo drive, that will output the signal, will output the status of your servo drive to a PLC or any partner. So your PLC, for example, for the first channel, you can receive the server ready. For the second channel, you receive the home is complete, etc. And here is the PL mode of your motor, of your servo motor. That is a very interesting, I think in my view, is very interesting mode, that you have a 99 position register, and each register will have their own setting. Then what you need to do is go to here, select which program they would like to turn on. For example, I would like to turn on program 3. What I need to do is I only need to turn on bit 0 and bit 1, and then trigger my command. So then you can choose a point-to-point, and you can use absolute positioning. You can use relative positioning or increasing position, etc. And for the data, it's actually the position set point of your motion tasks. And finally, in this tutorial, I will use FBD for the main control. FBD's function block diagram is a little bit similar to ladder, but it's also a graphic language of IC61313. But this function block diagram is like a circuit design. You will put so many AND gate or OR gate to control your logic flow, to pass the next signal to the next block, something like that. But it's not very difficult, and I think if you, after this tutorial, you know the basic of how to program the FBD. Okay, I think the discussion is enough in here. Then we can start to make the Codesys program. Okay, so now we open our Codesys project, and actually this project is very similar to my last tutorial of Codesys, and I just delete all the program that inside. There's no mapping variables here, and all the mapping variables to the modules are deleted. Okay, so now we can create a program now. The first thing is, as I mentioned before, that I will use FBD function block diagram here, so I need to create a new point in my project. Let me close all this editor in here and save my project, and go to applications, right click, add object, and point here, POU, and you can choose program, function block, or function in here. I will choose program in this tutorial. Maybe in the future I will also explain how to use function block and how to use functions. So here I will rename a new name for my program. This case it should maybe POU underscore servo, and add it. Before you add it, you need to choose your immersion language to FBD function block diagram. And great, now your first FBD program is created. But before we start the programming, there are some options I would like to show you. It will be very useful when you try to use the graphic program language in Codesys. Go to Tools and Options, and then slow down here. You can find a options called FBLD and IL editor. And then open here, that is up to the option. I prefer you to turn it on. The first one is show network title, the second one is show network comment, and the last one is show simple comment. So what is this one? Okay, I check this box and I will show you now. I will just define a test variable in here with a bool command called this command. Okay, and then I will go to here. So here is your first line of your program in FBD or ladder. In Codesys, all the program are managed by network. So here's one network, and then you can right click to add a new network below or upper. So first one, I would like to show you what is the network title. Network title in here. The first line of your network, it should be network title. So here, network title, right? And then the second one is network comment, right? Network comment. You see the color is different between network comment and network title. And then now, for example, I would like to show you what is this simple command. That's, for example, I right click, add this assignment here, assign contact to here. You'll see that is also a command that is displayed in upper of your variables. It is a simple comment. Okay, I think it's very clear. So now we need to add here to delete this one, delete all the parameters that I don't use in here. So I'll start the programming. that before I program it, I will define some variables that we'll use in this program. The first one, I would like to define two slots for in byte type. That is for me to map the data between my user program to the real hardware. In this case, it's WAGO's digital input and digital output. And second one, I just like my last tutorial, I will define a status of my switch 1 and also status 2. Okay, and then I'll define a couple of buffer memory that to let me to transfer the process input data to these variables. It is very useful because if you, I think I would not prefer you directly use the data to map to the hardware, because one time if you change the hardware or if you have any modifications, you need to change everything inside your program. But if you have a buffer, you only want to change the first line, that which variable to assign to that buffer. So the first one is I serve already. It is boot type, and it's I home complete. It's also a boot type, and the IPR command complete is also a boot type, and I servo alarm is also the boot type of variables, and then I position reach CHED, it is also the boot type here, and then I speed no 0 is also a boot type. Okay, after I define all the input buffer, and then I define the output buffer. So for example, Q servo on is equal to boot type, and then I'll have a Q command trigger. It's all the boot type in here. Okay, and then I have a Q alarm reset. It will be a boot type, and QE stop is also a boot type, and Q command PR bit 0, Q command PR bit 1, Q command PR bit 2. Okay, it's all boot type variables, and then I also have a command for me to output the status of my servo. Now is at the error or not, so I will define a Q switch alarm, a switch lamp. It will be also a boot type. And actually, when I open the software of my servo drive, in this case is JTEKT, and then open the software, then go to DIO, then you can find all the mapping. Now it's exactly the same what I defined here, but the position is opposite, because what signal that the servo motor will receive, it should be the output of my PLC, and then what signal that my PLC will be received is to be the output of my servo drive. It's opposite, right? Very easy, no big deal. And then I'll define some internal variables for me to use. For example, the first one is switch lamp. It will be boot type, and then PR command 1, PR command 2, PR command 3. It will be boot type in here. And now the alarm servo, it will be also boot type, and alarm need stop is also be boot type. And now have a system reset. System reset SET is a boot type data also. And then I have a servo start. It's a start command for my servo drive. It will also be boot type. And finally, I'll also define some commands for internal use. Commands reset is a boot type. Commands servo on, it will be boot type. And commands PR and SINT, it will be SINT type. And commands PR backup can also be SIND type. So actually, as I mentioned before, in here, this PL, I think it's a register position command. You need to select which register position that you would like to trigger. So I will use a number, a short integer that to manage this number. And then, for example, if I put a number 1 inside this command underscore PL underscore SIND, actually finally I will just turn on the bit 0. In the same theory, if I want to run the PL sharp 3, what do you mean the third of the position register, I just put a 3 inside these variables, then finally I will turn on bit 0 and bit 1. Then I will show you how to do it in the next 10 minutes something. Yeah. Okay, so and then I will need to know what is my last command that I execute successfully. So I have a actual PL is SINT, and now I have 2 timers for me to use. Timer P on, T on, T on. Okay, T on E 2 is also T on. Okay, and I can delete all this space that I don't use. Then I also define a constant. For me, sometimes maybe I will use it's always on bit. So AWAYS always on is a bool type. It will have a insert value equal to true. Okay, all the variables defined finish. Now I can start to write my program. So here is my program area. As I mentioned before, the graphic language that in Codesys, they will manage all the program in a network, inside a network. Okay, so the first one, I would like to insert execute block, right click in the end space, and then choose insert execute block. So you find a execute block in here, then you have a EN node and enter ST code here. EN is a you may imagine EN means enable. Okay, if you give a true signal to this EN input, then the program that inside this execute block will be execute. And then ENO is just a signal call. It's just the output signal, our feedback for you that your program is executed without any error. Very easy, right? Not big deal. And then so I would like to execute this program in any time. So I just can put a true in here. So this program will execute without any conditions. Okay, so and then you can just click the enter ST code here to enter your ST program inside. So for example, I will use servo ready. Okay, is equal to slot 1.0. I home complete is equal to slot 1.1, and IPL command complete slot 1.2, and IP and and alarm servo is equal to slot 1.3, and I position reach is equal to slot 1.4, and I speed not 0 is equal to slot 1.5. And now I have state switch of these two. I have the status of my switch. So I have switch state 1 is equal to slot 1.6, and switch status 2 is slot equal to slot 1.7. Great. Okay, all these the program defined inside. So as I mentioned before, that the slot 1, the channel 0 will assign its value to servo ready. So when you open the software in here, you see here DIO servo ready will be this first channel of my that will be inside my flow signal inside the digital input module. So that's why I assign 1.0. For same theory, the second one is home is complete, so with 1.1, 1.2, 1.3 to accept, I can access each channel inside my digital module, input module. Okay, the first one finished. Then I would like to add a network, so I will right click here and then put insert network below, and we have a new network here. So I'll just copy a little bit more, then I don't need to insert it so many times. The second one, I would like to create a reset flag that for me to reset my server drive. Right click, insert assignment. So you have a two value that you need to do, the left one and the right one, or the value of your left variables you assign to the right one. So in here, I'll put system reset, will assign its value to command reset. Okay, now it means the value of status reset will assign its value to this command reset. Very simple. Okay, then I would like to create an alarm for e-stop. The first one, I will need to put the signal inside, so I will right click and add empty box, and here I will use OR. So what kind of conditions that let me to trigger the alarm e-stop? It should be my switch, right? Switch status 2, and then I would like to invert the signal, so I would like to put a not gain here. So how can I do it? I just want to click the pin here, right click here, and then the occasions. Then you see a small circle. That means that this input will be not gain. It will invert the logic value of your variables. Then we pass it into the OR block. So I put a assignment here. So here it will be alarm e-stop. Okay. Then so now if the switch underscore status 2 have problem, then the alarm e-stop will be turned on, and I would like to keep it. I would like in self keep this alarm underscore e-stop until I have a system reset command. So I put an end block in here. I think here insert any box, then I put an end here. So then because self keep, right, so put a alarm e-stop here, and until I get a system reset, so I will need to invert the signal here also, and then put a command reset variables here. So here is the logic, very simple, but I'll try to explain it, and it is just a logic for you to self keep the alarms. Maybe you can just also set the alarm here, but I would like to use self keep in this case. Then until this, and okay, so I will create one more alarm that is called servo alarm, and the signal is received from the servo drive. I will right click, insert empty box, and put an OR in here, same. And then if my servo alarm, it means the servo drive output a alarm signal to me, then I need to trigger the alarm. So it should be alarm servo. Okay, then same as here, I would like to self keep this signal alarm underscore servo. I will right click it and insert empty box, and then same theory, put an end block in here and self keep alarm servo, and put a not signal with the until I reset the alarm. Okay, so actually these two logic is exactly the same, but just have different trigger condition and with different output. Okay, so and then I would like to create a logic for me to turn on the switch lamp if there's any problem, any alarm trigger in my program. So I will right click here and put insert empty box and use or block. And here is alarm servo or alarm is stop, and assign a output to this block. It should be the switch lamp. Okay, switch lamp here. Okay, and then the basic finish. Okay, so now I would like to create a logic for me to turn on the servo drive. And before that, I would like to copy the bit network here. So when I would like to turn on my servo drive, I will have different conditions. So I will put a AND first. Okay, so go to boot operations, go to AND, and here then I would like to use this start command to turn on my servo drive. But I don't want to keep. I would like to use a gauge detections. So let's right click here, right click, and select gauge detection. So now this signal will be true only when servo start variables is the signal change from false to true only. Okay, so and then I would like to add one more input. So what kind of input do I need? When the servo motor start, I need to make sure now is no e-stop error, now is no servo error happen in my system. So I will put two logic in here, and then here I will put alarm, alarm e-stop, and alarm servo. Okay, so now this signal will be only true when my servo start variables is from false to true, and also there's no alarm trigger inside my system. Okay, so then I put a OR block in here. It's be OR block, and I'll assign the value first. It should be the command to turn on the servo drive. Command ds. I think it's command servo on. Do you have? I think I didn't define this one. Command maybe yeah, here. Okay, I'm spelling wrong. So it should be here. Command servo on, and I would like to self keep these variables until error happen. So I would just same as this logic. I put a AND block in here, and I will use the same variable to self keep this commands underscore servo on variables last value, and then to add some interlocks to make sure that there's no alarm is raising in my system now. So it works. Now it's the whole logic. Now the servo motor will be stopped depend on this signal, and you self keep until there's an alarm happen. Great. And then I would like to create one more execute block in the next network. Here, and I will put true in here, and then so what is the logic inside that I don't want this servo start command to always turn on inside the program. So I will create a timer program inside. In is equal to servo start. It means you start to count the time when servo start is become the true, and I'll give a 1 second delay. 1 second. Okay, then if to_1.q, and I will turn off the servo drive, so the servo start command again, ALSD. Okay. Okay, so this one finished, and the next one I will show you how I will create a program to reset my command, my PR command, because it's not make sense to always keep your command, the PR command, as have some value inside. You should reset it to 0. Maybe you can, in my mind, I would like to reset it to 0 if there's any error, or the server is not ready, or this variable has some value is not accept for inside my program. How can we do? Very easy. Just right click and create a empty box with all logic. Okay, and the first one, if alarm is stop is turned on, or if alarm servo is turning on, and then I'll add input here, or now the servo motor is not in ready status, or my command value is not in a acceptable range. How can we do? I'll use a block called LT. LT is less than a compare block, compare my command PRSINT and 0. So if this value is, my command now is less than 0, it means there's something wrong of my command. I need to reset it. And then so how can I reset it? I can just go to here, right click, insert a empty box, input move in here. Oops, it's not be this one, delete one. I need to use with the ENO. Okay, move. So move what? Need to move 0 to command PRSINT. Okay, and then I would like also to remove, to reset my current my last position register, my last position register. How to do this? Put it to 0, and here is put actual PR. So if there is a alarm, or the servo drive is not ready, or my command is not in the acceptable range, I'll reset the command and also reset the last command that I received, that I execute successfully. Okay, so and after that I would like to send the command. So what is, I'll say send the command to the servo drive. I think it's here, this one. So it will be very important bit for me, for important signal for me to trigger the register position command. It will be choose by 0, 1, 2. That is depends on the command I define here. So how can you do in here? I will, let's put the end block first. End block. So I'll have servo's condition for me to check before, that that's now I can now the condition is allow me to send a command trigger command to the servo drive or not. So the first one will be, I will be check this command is equal to 0 or not, because if it is 0, it is not a acceptable command range. So I will right click here, right click here, and insert empty box. This time I'll use any, not equal. It means, so if this one is not equal to 0, it means there is a acceptable range of the command is input in these variables. And then and then okay, and then I will move using move command. Then I'll move the command to the command backup. Then I'll make sure that this program only trigger one time. And then I also in here save first, and I will insert a branch, and then insert a assignment. Then I will choose Q command trigger to let me trigger the command. And because this program only allow you to run in one scan only, so I will put a set instruction here. Click here and right click and choose set. Then you will see a little bit S in here, so when this logic is run, then Q command trigger will be set to true. Okay, very clear. And then I would like to add one more condition here. So insert empty box and put an N signal. Put any signal here. And you need to compare what? You need to compare your command and your last command. You need to make sure now you receive a new command, but not just a command that you send the drive before. It is very common logic when it's very common logic for you to control the server drive. Okay, so now we can trigger the server drive, and then we need to select which program you need to run actually inside your server drive. How to do it? For example, you need to put a block first. I think is put block first in here, and then if I server ready, so means the server is ready to run, and input and the control voltage is also okay, and the servo motor power supply is also okay, and this servo ISO ready will become the true. And then you need to put AND logic in here. So AND and what? And your command signal dot bit 0. And then for the result, you can put the assignment here, PL command 1. Okay, and then add branch in here. I think it's here, right? Here, branch, and put a AND block again, and block, and put one more branch in here, branch here, and then add one more block in here. Okay, here, and then put and use AND block, and put the assignment, because you need to assign the output, right? So here is also a assignment, and here put N, here's N, and here's a bit 1, and here is bit 2, and then here is PL command 1, PL command 2, and here is PL command, PL command 3, right? Okay, so now you can separate your command into bit and then to assign to the output. Great. And then I would like to add a new network again. Okay, so what network I need, is the next program I need to do is, first I'll need a input a empty box, and then using move instructions. Then for the EN, I will choose I position reach. It means my servo motors is finished its motion task. It means in this case it means now the actual position is equal to the command position. And then I put a gauge detect in here, gauge detections, and the command this time the command will be equal to actual PL. So it means that if the drive is finished its motion task, and I put my command, the command that I execute inside, I execute the program and send to the drive, and then it should be the last position register that I execute. So I move this value to the actual value. It's a very also very common logic when you have so many stations. So I now move to station 1. I would like to move to station 1 when the servo drive he detect I send back a finished signal to you, then you can know now your servo drive is finished its task, and it should be station 1. And so it's just now you would like your drive go to station 10, and you send the station 10 command to your drive, and the drive send back you a signal called motion task finish. Then you know now you're in station 10. So it's a very simple logic, but very common when you use this control servo drive. Okay, so next I would like to create some assignment value. For some insert assignment, the first one is command servo on. Why servo on? Then I put to Q servo on. Okay, and insert one more assignment. Command reset is equal to Q command Q alarm reset. Okay, and then put one little bit more in here, and then I will have a assignment again. So NPL command 1 will assign the value to Q command PL bit 0, and copy paste, and command 2 will be equal to Q command bit 1, and then Q command 3 will be equal to Q command bit 2. Great, finish here. And then you need to output the e-stop signal to the drive. So what can I do here? It's the same what you do before. Alarm e-stop is equal to what? Q e-stop. And finally, insert assignment, switch alarm, switch lamp. It means that there's the alarm inside your system. Then you turn on the lamp, let the operator know the current status. Great. And finally, I would like to reset the trigger command here. Command trigger here, because now it's only set in here. You need to program the reset program. So let's right click, put a execute block in here, and for the end, I also put always on or the true, up to you, but I think true is better. True, and the inside I will trigger a timer. In is equal to Q command trigger. I give this timer a 1 second delay, and if ton2.q, it means the timer is trigger, I will reset the command to false. Great. So finally, I only need to assign all my output back to the process IO. So how can I do it? Slot 2.0 is equal to Q servo on. Slot 2.1 is equal to Q command trigger. slot 2.2 is equal to Q commands PR bit 0, slot 2.4 is equal to Q command PR1, and slot 2.5 is equal to what? Q alarm reset, and slot 2.6 is equal to Q alarm reset. Oh, no. E-stop, sorry, E-stop. I think not reset. E-stop, and slot 2.7 is equal to Q switch lamp. Great. Okay, now we finish here. Then we go to the main program. Then we can call it POU servo to call my servo program. And then we can now to map the modules. Here, go to your DIO input module and search slot 1 and map it. And do the same thing for slot 2, and map it. Great. Now simply all stuff finish. Then we can go back to device, scan network, and choose the PLC you like to connect, and this time is a WAGO PLC, and log in. Great. And now it seems the program is logged in. Now we can go back to the servo program to see what happened now in here. So now the status is true, and okay, I think it's no alarm here right now. Let me see in here. Okay, there's no alarm, and iServo is in ready status, right? So I would like to turn on my servo drive first. So go here, this bit, servo underscore start, right double click, and right click, write your value, and then go back to software. Now you see the servo ready is turned on, and servo procedure complete is turned on, and modal reach position is turned on. Okay. So the next step is I would like to insert some value inside. For example, here, or maybe I expected to adjust the camera and my Codesys editor. Okay, now the screen is assigned, look like very good. Then I can turn on the command here. For example, I give a command 3 in here, right click, write all video. Oh, you see the drive's turn is running and turn to position 3. And then for example, I give a new value to him, this servo drive, and 5, right click, write all video. Doesn't work. Let me to see what happened here. Okay, let me to try other value. Maybe there's too close between these two values here. 6. Okay, what happens inside here? 7. Okay, don't know why it doesn't work. And there's no error in here. So maybe okay. Turn 2. How about 2? So there's some error in here, so maybe we can stop our PLC again, and then just wait a second, let me turn our PLC to off. Okay, now PLC off, and we'll turn it on again, and let me turn on the E-stop. Okay, and then reset my drive again. Reset my drive. Okay, and then turn on my drive again. Okay, and try again. Let me turn to position 5. Let's see if it doesn't work or not. Okay, it works. And for example, I turn to position 3. I think it should work. Okay, it works. Great. Okay, here, and the I position bridge is also turned to true. It means the positions work. Maybe I need to reset my drive first. Okay, and I hope you like my videos, and Here's finished. I show you how to use FBD to do some basic programming, and I use the JTEKT Servo Drive. I use the JTEKT Servo Drive to let me to know how to control between a WAGO Codesys PLC to the Servo Drive. I hope you like my videos, and I hope I can see you again in next time, and please have a good day. See you next time. Bye bye.